Hi guys, my name is Avinash Kumar. Welcome to my channel Stochastic Programming. So in this video, we will talk about NUMA architecture, which is non-uniform memory access. I know it is more a theoretical topic. However, being a software engineer, we need to understand what are the trade-offs associated with NUMA and UMA, which is uniform memory access. So let's get started. So in order to understand NUMA architecture, first we need to understand about the UMA architecture, which is uniform memory access. Now, all the typical normal desktop computers which we use for the purpose of development or for the purpose of browsing web, they build on top of UMA architecture. So that's the reason when you open the task manager, you will see that the NUMA node is actually disabled. So it means we are working on the normal system, right? So what does this mean? It means that we have one single CPU which is interconnected with a RAM. This RAM is more like a volatile memory. They both are interconnected with each other through a channel called bus. Now this here bus is not something like a vehicle. It is a channel which collects the data from RAM and pass it to the CPU. Now this is what UMA does, where we have one CPU which is interconnected with RAM. Now how we can process information more quickly. I know we have multiple cores which serves the purpose of multi-threading, or which serves the purpose of true parallelism, but nowadays we need more parallelism in the system. Now one approach is to increase the number of cores in CPU and achieve true parallelism. The other approach is to add more CPUs. Now, when adding multiple CPUs in the system, in case of UMA architecture, those CPUs should be connected with centralized non-volatile memory. And the problem with this approach is, since we have the limited size of the RAM, the page fault will increase and the hit rate will decrease, because, as I mentioned, now two CPUs are consuming data from the RAM, and due to the limited size, it can be possible that when CPU 1 consumes the data and the data is not available in the RAM, it will collect the data from hard disk and put it in the RAM, and if the size of the RAM is already filled, it will remove some sort of a data. And let's say if that data is processed by CPU 0, then it will again go to the hard disk and put data in the RAM. So overall, we are adding the cost of round trip. So the purpose of achieving true parallelism and improve the performance of the overall application is actually gets violated, because when we actually add multiple CPUs, we thought that the performance of the overall system will increase, but due to the limited size of the memory and due to the centralized connection, we are not actually achieving that purpose, but we are actually decreasing the overall performance. Now, how to avoid this? Now, the one approach is to decouple RAM from the CPU, which means that every CPU will have its own memory, and both these CPUs will interconnected with each other. Now, this architecture is known as the non-uniform memory access. Now, why is that non-uniform? Because when accessing to the local memory, the time consumed by the CPU1 will way more less when accessing to the remote memory. So this is actually good in the sense, because in case if CPU1 wants to consume any data and that data is not exist in RAM 0, in a typical normal computer, it will go to the hard disk and ask for that data and then put it in the RAM. Now, however, since we have this NUMA architecture, CPU1, instead of searching in the hard disk, which is typically 1 terabyte or 2 terabyte long, it will collect that data from RAM1, which will be more like a 4 or 8 GB in size. So this is more faster. Now when we talk about the NUMA node, typically one CPU is bind with one RAM. So here in this case we have two NUMA nodes. So this is a typical architecture. However, there can be a systems where multiple CPUs are interconnected with RAM. So here in this case, if you can see CPU 0 and CPU 1, they are connected with RAM 0, so they are serving as one node. Similarly, CPU 2 and CPU 3, they are connected with RAM 1, so they are serving other node. This means that when CPU 2 wants to access RAM 1, it will be a local memory access. However, when CPU 2 wants to access RAM 0, it will be a remote memory access. So that's why the access time when accessing the RAM is actually different in both the cases. So it is called the NUMA architecture.